In geometry, if you want to fare well, you need to know the parallel lines. They never touch, they're always the same distance apart. It's as if they don't like each other much, and there's only one thing they can.
Hello, guys, and welcome to the Kearney Math Show. Thank you all for tuning in today. On today's episode of the Kearney Math Show, we are going to be featuring an 8th grade topic in which we are talking about parallel lines that are cut by transversals and the angle relationships that correspond with those. So before we get started, go ahead and write entry number 5 at the top of your mini lesson and go ahead and read our learning goal for today. So entry number 5. So what I'm going to do, our learning goal is that by the end of today, I want you all to be able to explain to someone how to solve for missing angles if you have two parallel lines that have been cut by a transversal. So be able to explain to someone the different angle relationships that are created and how to solve for missing angles. So the top part of this mini lesson is a good bit of review. So I'm actually not going to take time to go over that with you guys. My expectation is that you go back and complete those problems later as a good refresher of solving for missing angles. But I want to go directly to our new material. So if we're going to go, let's go down to the essential vocabulary. Really to be able to understand this stuff, there's a lot of vocabulary that goes into it. So the first thing is let's just talk about parallel lines. So with your arms, if you want to just show what parallel lines look like. Parallel lines are lines that lie on the same plane, but they never do what? They never touch. And because they lie on the same plane and they never touch, which means they're continually going at the same constant rate, thinking back to what we talked about a few months ago, they actually have the same what? What do you think they have? They have the same slope. Whoa, Miss Kearney's having a hard time spelling. They have the same slope. They're the same. They're depending on whichever direction they're going to have the same slope because they never touch. They never get steeper. They never get flatter. They have the same slope. Now, if we take these parallel lines, so I'm going to just redraw them for this next picture. If I take these parallel lines and I actually draw a line that cuts through them, that is known as a transversal. A transversal is a line that cuts through two or more parallel lines. And that transversal also, it clearly doesn't have the same slope as the parallel lines, but it does continue with the same constant rate. So it's going to continue going at its same straight. It's very linear. Okay. So far we've got parallel lines or lines that never touch. Transversal is that line that's cutting up through them. Once that, so I'm going to draw it again. I'm going to keep drawing the same picture because we're keep adding on more vocabulary words. So we have parallel line, we have our transversal, and if you look, there are lots of angles that have been created. For me, I see 1, 2, 3, 4, 5, 6, 7, 8 different angles that have been created. Okay, and I want to highlight the ones that are something called corresponding. Corresponding angles right here are in the same position on parallel lines with a transversal. Okay, so for example, this one here is corresponding to this one. They're in the same spot, okay? This one up here is corresponding to one of the other parallel line that's down here. They're kind of in that same position. They're just on different parallel lines, okay? This one here is corresponding to this one, and let's put a heart here, is corresponding to this one, okay? So what's really cool about corresponding angles is they're actually equal. So if I knew that this one up here was 110, that means this one down here is also 100. Oh, sorry. Excuse me. Corresponding, this one's 110. Okay, so corresponding angles, they're in the same position on the parallel lines, just on different parallel lines. Okay, so now the next thing is something called alternate interior. So I'm going to draw another picture. I'm going to give myself some room here. So I have two parallel lines again. Actually, let me draw a different color because I'm starting to get blurry with all of them looking the same. Okay, my two parallel lines, and now I'm going to cut it by a transversal. And if you look, the pairs of angles between parallel lines on either side of the transversal. So this one here, and it's alternating on the other parallel line, those are known as alternate interior. The reason why is because they're alternating on either side of the transversal, but they're interior, they're inside in between the two parallel lines. Now, what's really cool about them, other alternating interior would be this one is alternating to this one, and they're in between those two parallel lines. So they're alternate interior. What's really cool about them is they are also equal. Okay, so if this one, if I knew that this one right here was 50, then that means this one's also 50 because they're alternating interior. Okay, and the last one is alternating exterior angles. So it sounds like alternating interior, and it's actually pretty much the same thing. They're just on the exterior. So let me draw two new lines, parallel lines, cut by transversal. And now if they're alternating exterior, that means they're on opposite sides of the transversal, but they're on the exterior or the outside of those parallel lines. So this one and that one, they're alternating on both sides of the transversal and they're exterior of the parallel. Okay? Other two would be this one and this one. They're alternating and they're exterior. And what's really cool about them is they are also equal. So if I know that this one here is 70, then I know that this one's 70. Okay, so there are lots of angle relationships. So if you need to pause the video and just learn those vocabulary words, because that will definitely help you. Okay, so let's see how we can use this to help solve some problems. So here is, I just want you to take a minute. You can actually pause the video if you would like, and go through and start naming some. I'm going to name a few just to get you started, but I want you to go back and name some more. So it says name angles that are corresponding. So corresponding angles, they're on the same spot, just on different parallel lines. So angle 1 is corresponding to angle 5. Okay, because they're on different parallel lines, but they're in the same location in comparison to that transversal. Okay, other ones, angle 2 and angle 6. Okay, you can go back and add some more. Alternating interior. So that means they're going to be inside the two parallel lines. So we've got to do inside the two parallel lines, but on alternating sides. So 3 and 5. Ooh. Angle 3 and angle 5. Okay, alternating exterior. I see angle 7 is alternating to angle 1. And vertical angles. Vertical, I see angle 1 and angle 3 are vertical. Okay, you guys, like I said, can go back and add. There are lots more that I'm not listing. I'm just kind of going through these quickly so we can get to some of the math problems. Okay, in supplementary, remember we said supplementary, they add to 180 degrees. So you can look up here and see a lot of angles that add to 180. Just to name one, I see angle 5 and angle 6 are 180. Okay, there are lots of them. You could list a bunch of them. So let's get down here to some math. Okay, so it says in the above example, line R and S are parallel and cut by transversal. If line T, called line T, if angle 3, so let me come up here and erase all my scribbling. It says if angle 3 is 68, use what you know to find the measures of the rest. So we're going to come here and we're going to put angle 3 is 68. Okay? So see if you can find some of the other measures. So for me, if I want to try to figure out angle 1, what do you know about angle 1 and angle 3? We said angle 3 was 68. What do you see that angle 1 and angle 3 are? They're vertical to each other, right? If I look up here, I see that these two are vertical, 1 and 3. So if angle 3 is 68, that means angle 1 is 68. Okay? What do you notice about angle 1 and 2? Angle 1 and 2 are on top of that straight line, so they're supplementary. So what do they need to add up to? 180. So I got to figure out 68 plus what would give me 180? So angle 2 would be 112. And what do you know about angle 2 and 4? If this is 112, what does mean angle 4 is? 112. Okay? And now, the fun part is I can actually use all the things I just learned about alternating interior and corresponding to find the rest of the angles. So for example, angle 2 is corresponding to angle 6. So that means that angle 6 and angle 2 are congruent. Angle 5 is corresponding to angle 1. So that means angle 5 is 68. Angle 7 is vertical to 5, so we know this is 68. We know this is 112. So angle 7 is 68, which is also corresponding to angle 3. And angle 8 has to be the same as angle 6, so 112. Okay, so there are lots of different angle relationships you can use to find these missing angles. So, I know that was a lot of information, so I want you to take time to go back and look at those vocabulary words. But our big thing we're taking away is that when you have two parallel lines cut by a transversal, those corresponding angles are equal, the alternate interior angles are equal, the alternate exterior angles are equal. So, if you want to go ahead and try the next example and see if you can solve for some of those missing angles. Okay, and come to me with any questions you've got. All right, good luck, guys. Peace out, Rainbow Trout. Love you, mean it.